All right, welcome to the chapter 5, learning target number 5 and 6 video. This is going to be I can determine the part given the ratio, and I can determine the whole given the ratio. So it goes back to whether ratios can be part to part or they're part to whole. But as you guys are aware, any part to part ratio can become a part to whole, and any part to whole can become a part to part. Okay, so that's where this goes. All right, so go ahead and flip in your notes to page, I don't even know what page it is. It's right here, page number 13. Page 13. Okay? Okay, now we can look at this and we can say, oh, okay, equivalent ratios. We can multiply by 4 there. We can multiply by 4 there. Okay, that's 48. Now that's all well and great. I'm glad you guys know that. But what I'm trying to get you guys to see is it's not always going to be that easy, and you guys are figuring that out on your own. So now let's practice that cross products method, okay? Which is where we cross multiply 12 times 20, okay? 12 times 20, and we get 240, okay? And then we divide by whatever number we have left over. Divide by 5, okay? 48. That's what we said it was. That's the answer. Okay, cross products. You multiply the numbers that are diagonal from one another, and then you divide by the other number that's there. Okay, what is the value of x? Again, you guys can look at this and say, oh, I know that I'm dividing by 4 to go here. So what would I divide by 4 to get 3? You know, but I just don't, I think, you know, that's great if you know that, but that's in these special circumstances it works. It doesn't always work that well. So let's cross multiply the diagonal numbers and then divide 4. 16 times 3 is 48. We divide that by 4, we're going to get 12. Okay? Again, now we're identifying the whole because that bottom number is the whole. Okay? 6 times 60 is what we got to do because those are diagonal from one another. Okay, that's going to be 360. I knew that because I knew that 6 times 6 is 36, and then you just tack on your 0. Okay? And then we're going to divide it by 40. All right? Now, since both these end in 0, I'm just going to cross them off for a minute. I'm going to get rid of them. And there you go. 36 divided by 4, 9. Okay? Hopefully that makes sense. If you have to use your calculator, that's what's fine. It's a resource. Use it. 6 times 60. Okay? That's going to be 360, like I said. Divide by 40, 9. Okay, so your answer is 9. And then you should always check these. You should always check them to make sure they are equivalent. Make sure you didn't make a silly mistake. So do 6 divided by 9. You're going to get 0.6 repeating. Okay? And then 40 divided by 60, let me do that in my calculator real quick. 40 divided by 60, that gives me 0.6 repeating. Now the best way I'd rather you guys do it is just simplify them. So type in 6ABC9 and 40ABC60 to make sure they both give you 2 to 3. And they will. Okay, that's the same thing we did in chapter 4. Okay, so make sure you got that. Here, I'm going to cross multiply. 25 times 8. Now, a little trick here. I know that 25 times 4 is 100. So there are 2 sets of that in 8. Okay, so I knew it was 200 just because 25 times 4 and 25 times 4 would be 100 plus 100. So that's 200. And then I'm going to divide it by my other number. 200 divided by 5 is going to be, let me get out my calculator. 200 divided by 5, 40. Obviously, I knew that. 40. And then always check. Okay, and here, cross multiply divide, 12 times 50. The trick would be 12 times 5 and then just add a 0, but I'll just do it. 12 times 5 is 60. Oops, it's 12 times 50, which is 600. And then we're going to divide by 20. Okay, we can use a little trick here. Get rid of 1 0, get rid of 1 0. 60 divided by 2 would be 30. Okay, and then put it above your fraction there, or ratio, and then simplify them both. This simplifies to 3/5, 3 to 5. This is going to simplify to 3 to 5. So they are absolutely equal. Okay? So we've been doing that for so long that I don't think it's really necessary. I mean, I could keep going on and on here forever doing these, but let's just skip them. Okay, let's go down here now. If there are 2 boys out of 10 students, what is the ratio of boys to girls? So right there is your initial ratio. So we always start, I call that, actually, I haven't even used this terminology yet, but I used it last year. I call that my fake ratio. Please write that. The fake ratio, it doesn't mean that there are exactly 2 boys out of 10 students, okay? It just means, okay, for every 2, that means there are 10 total students. So that means if there were 8 boys, you'd have to do whatever you did from 2 to become 8. And that's kind of what this is all about. So I always start with my fake ratio. So we have 2 boys out of 10, maybe I like to put total, like 10 total students, just so I remember. Okay? And then it's gonna ask me here, okay, well then what's my ratio of my boys to girls? This goes back to way back when on a review sheet from, I don't know, it's been a little while, but I remember I had you guys, remember the chairs? There were so many chairs and tables in a computer room. Do you guys remember that? And I said you have to find your edge pieces. Hopefully that's ringing a bell, I hope. Should. And the edge pieces were, let's take this ratio and let's get every piece of information out of it that we can. I know that there are 2 boys. I know that there are 10 total students, but there's always a third piece of information. If there are 2 boys and then the rest are students, 1, 2, 3, 4, 5, 6, 7, 8, right? That makes 10 total students. How many of them are of the other variety? In this case, you got boys, so these are girls. So that means there are 8 girls. That's my edge pieces. Build from that. It helps you get your thoughts straight. So what's my ratio of boys to girls? Well, my ratio is 2 to 8. 2 boys to 8 girls. Are we done with that? No. You have to simplify always. Okay? I know they're both even, so they both have a factor of 2. So that is actually the same ratio as 1 boy to 4 girls. Okay? What is the ratio of girls to total students? Let's go up to my edge pieces and refer to that. Okay? I know there are 8 girls out of 10 total students. We got to simplify. They're both even. So I divide by 2 to the top and the bottom. It's going to be 4 to 5. So 4 girls to 5 students. Okay? This is where it gets a little bit harder, I guess, kind of, but not. If there are 70 boys in the phys ed class, so right away, I know right now, one of my labels is going to be boys, okay? And it's going to be 70 right here, okay? Remember, I always leave that first ratio. I leave my fake ratio in that first ratio right here, the one on the left. Okay, I always leave that one as my fake. So that's the one that I'm building from my edge pieces because that's the fake ratio. That's the fake stuff. If there are 70 boys in a phys ed class, I want to know how many of them are girls. So that means I'm comparing the number of boys in phys ed to the number of girls. Okay? This is what I don't know. Right here, I'll put it in yellow right there. That's what I don't know. That's what I need to find out. So we got to go back to our edge pieces up here, and we got to say, okay, labels never change. That's going to be boys. That's going to be girls. Now let's build our proportion with our edge pieces. Okay, I know that there are 2 boys for every 8 girls. Okay, now we can just cross multiply and then divide 2. Okay, so 8 times 70 equals 560. We divide that by 2. That is going to be 280 girls. Holy cow, that is a lot of girls. No thank you. I don't want to be the gym teacher in that class. Anyway, 280 girls right there. And that's how we did it. So we build from the information. We find out what are they giving us. They're always going to be giving you a piece of the information, a piece of the puzzle. If you want to think about it like this, give us the piece of the puzzle and then they're going to be then asking for another piece. Okay, and you got to figure out what those pieces are. Okay, now if there are 140 total students, so now let's go ahead, build. So I'm going to put total, because again, we always put our whole on the bottom, right? It doesn't make sense to put 140 up top because we're always we're talking the number of boys out of. So it's giving us the total number of students, and that's why we put it right there. And then it's asking for, okay, if there are this many students, how many of them are boys? So I know I'm going to be comparing boys to the total number of students. So then all my labels are going to be boys to the total number of students. Okay? So I got to go up to my edge pieces, and I need to know how many boys, what was my fake ratio up here that I could build from my edge pieces. I know that there were 2 boys out of 10 total students. Okay? Now I can cross multiply and divide by 10. So I do 2 times 140 equals, and then I'm going to divide by 10, and I'm going to get 28 boys. 28 boys, okay? I hope this is really coming clear. We've been doing them on review sheets, so I think they're probably coming together. Now, these are the basic ones, so don't think, if you think these are easy, good job, but they do get a little bit more challenging. Okay, here we go. There are red and blue marbles in a bag. The ratio of red to total is 7 to 11. What's the first step? I hope that every single one of you right now is saying, do your edge pieces, because that's step number 1. Let's do the edge pieces. Let's get those edge pieces. Remember I said like a puzzle. We got to find those pieces of information, those edge pieces of a puzzle first, and then build from there. So I look here and I say, okay, I know that the ratio of red, oh boy, whoops, the ratio of red to total is 7 to 11. So that tells me that red goes with 7, and then total goes with 11. So that means there are 7 red. Okay, we know that there are 11 total, and then that leaves how many that can be blue, because we know there are also blues in there. There would be 4 blues remaining. Okay, now we've got our edge pieces, we're ready to roll. How many blue marbles are there? How many blue marbles? Well, pretty simple there, 4 blue. Okay, we just subtract the total amount from the number that we know, the part. Okay. Subtraction is used when you're given the whole, you're trying to subtract out a part to find the other part, okay? What is the ratio of red to blue? Red to blue would be 7 to 4. And you could show it any of these ways, okay? Okay, let's go to the next page. Go all the way up to the top. Paste my edge pieces back here. Yeah, that almost worked. Oh, there it is. Oh, this is taking too long. Okay, there we go. I know, it's awesome. The bubble letters are awesome, aren't they? Okay, there we go. Okay, so now it's going to give me a piece of information, and then it's going to ask me for a piece of information. So let's start right here. We start with our proportion. And we say, okay, what information are they giving us? Okay, they're giving us 52 blue marbles. Blue marbles. Okay. It wants to know how many total marbles there would be then. Marbles. How many total marbles there would be. Okay. So we've got this half of the proportion done. Now we got to take this proportion, the one on the left, and we got to build from our edge pieces. This is blue. The label here is blue marbles. So this is going to be blue marbles. This is total, so this has to be total. So how many blue marbles? There are 4 out of 11. Okay, now we're ready to cross multiply and divide. 11 times 52 divided by 4, 143. That was how many total you would have. And then once you get this point, again, guys, you can always, just to check, simplify your ratios or divide them, turn them into decimals. 4 divided by 11. Okay, that's 0.36 repeating. Right? 0.36 repeating. Okay, let's check 52 over 143. Make sure. 52 divided by 143, 0.36 repeating. So that's how you really can be certain to check yourself. Okay? If there are 35 red marbles, how many blue marbles? So now they're saying, okay, I got this many red marbles. I want to know how many blue marbles that would be. Now we got our ratio set. This is what do I have marbles? This should be red should go there, red should go there, blue should go there. Now let's build from our edge pieces. I know that the ratio of red to blue is 7 to 4. Okay? You could use cross products here and multiply across and then divide, but I just saw right away that 7, I know that 7 times 5 is 35. So I got to do times 5 here, and that's 20. You can always use that method of just seeing what the equivalent ratios. That's the best way, really, but it doesn't always work. That's the only thing. Okay? Again, check it to make sure. Let's do it. Okay, let's do our division of our ratios there to make sure they give us the same problem. 7 divided by 4, 1.75. 35 divided by 20, 1.75. So I know they're equal. So I hope this is making very good sense for you guys. You know, my students last year had a lot of success with this, so I think you guys will as well. So I'll see you guys tomorrow.